trigonometric applications. It says in today's lesson we will be learning how to solve a triangle. This means that we will find the missing measure lengths of all sides as well as all angles. There are two theorems, old theorems, that you will need to review, need to remember. Triangle sum theorem, all the angles of a triangle is add up to 180. And the second one, Pythagorean theorem, hopefully we remember. A squared plus b squared equals c squared, where a is the two legs and c is the hypotenuse. First example. It says find side x of the right triangle. We're going to use our sine, cosine, and tangent to do this, and let's review before we start what sine, cosine, and tangent are. Using SOHCAHTOA, sine is equal to what over what? Good. Cosine and tangent. So in our first example, it gives us a triangle. Right triangle. This only works for right triangles, what we're doing today. 57-degree angle and x and 6. Hypotenuse is 6. Side x, would that be the opposite side or adjacent side of 57? Opposite. Adjacent would be this bottom side. That would be the opposite side. So this is opposite. This is hypotenuse. So SOHCAHTOA, which we're talking about sine, cosine, or tangent here. Sine. Sine is equal to, so what I want you to do, let's start out with the sine of your angle is equal to the opposite side over the hypotenuse, and we just fill in what we do know and solve the equation. Here you have three unknowns. The theta, the opposite, the hypotenuse. You have two of those pieces of information given to you. Plug in what you do know to find out what you don't know. The sine of theta, do we have theta? 57 degrees. Do we have opposite? That's your x. Hypotenuse is 6. The actual solution to this, get x by itself, move 6 to the other side. X would equal 6 times the sine of 57 degrees. Make sure that you are in degree mode, and you just type that in. After it comes up, second quit. You gotta notice that graph's on there every day. So you have 6 times the sine of 57, make sure we're in degree mode. We're not. Degree. Second quit. 6 times sine of 57, you get 5.03. X equals 5.03. There's your answer. So the opposite side, 5.03. Any questions? No, that's all. You just have to find x on the first one. We're not solving the whole thing. You could, if you want to find the other side, you could use Pythagorean theorem after that. Use some common sense in these problems. Your hypotenuse should always be the longest side. So if you got something like 7.8 there, it's wrong. So since 5.03, that's fine. It's a little bit smaller than the hypotenuse. This side, let's see how much more common sense we have. Would this side be longer or shorter than 5.03? Because this is a 33-degree angle, right? So 33-degree angle, this is not drawn to scale by any stretch of the imagination. So since you have a smaller angle, this should be a smaller side. Bigger angle, bigger side. Any question? Next problem. I'm going to try to draw it like I've got it there. Right triangle, 5, 12, 13, and theta. SOHCAHTOA. We're missing what? Theta. Missing the angle. What do we have? We have all three of them. So which do we use? Any of them. Does not matter. Let's use one that we didn't use that time. Let's use cosine. The cosine of your angle is equal to adjacent over hypotenuse. So therefore, yeah, theta, we don't know. Adjacent is, careful. Adjacent is 12. Hypotenuse is always across from your right angle. This is upside down. 12 over 13. If you're looking for an angle, this is very close to this. If you're looking for an angle, because we've got to somehow get rid of our cosine, we're kind of moving our cosine over here. To get rid of, or to figure out an angle, you will always use that inverse cosine button. That's kind of how you move cosine from one side to the other side. So you'll do inverse cosine of 12/13, which is right above cosine. So inverse cosine, 12 over 13 gives you what? 22.62. We'll call it 23 degrees. So theta, 23 degrees. Because it's going to give you find cosine of angles. You don't have an angle. Okay? If you're looking for an angle, then you're going to have to do inverse cosine. It's kind of like solving an equation like 5x equals 15. You got to move the 5 over. You got to divide by 5 to get x by itself. To move cosine over, you take inverse cosine. Okay, that's how you figure out an angle. If you did it with sine, this is how you'd work it. Sine of theta, this was theta, equals opposite over hypotenuse would be 5/13. You would type it in. Theta would be inverse sine of 5/13. Because again, you're looking for an angle. If you got your sides, you're going to have to use inverse to find your angle. Any questions? Okay with that? And that would give you the same answer if you want to test it out. Inverse sine of 5/13 should be also 23 degrees. Oh, by the way, before we move on, this was 23 degrees. How could you find that third angle? There you go. 90, 23 is 113, so this should be 67. Or the easy way, if this is 90, then these other twos also going to have to add up to 90. So 67 and 23, that's 90. Does that match up with what I said a while ago? Smaller angle, smaller side. Bigger angle, bigger side. Next problem. Should finish early today. On your notes, if you want to put, that's supposed to be an angle symbol right there. It says A is 8, and measure of angle A is 40. Let me give you a little bit of heads up on this. Goodness, it's terrible. There we go. Angle A, side A are across from each other. Angle B, side B are across from each other. Angle C, side C is across from each other. And that's going to be your hypotenuse and 90-degree angle. So this would be angle C, this would be side C. If this is angle A, this is side A. If this is angle B, this is side B. So you're given side A is 8, and you're given angle A is 40 degrees, and you're asked to solve it. Solve the right triangle. When I say solve the right triangle, that means tell everything else about the triangle. I want all three angles, I want all three side lengths. Yeah, that's the easy one. Angle B is 50. Any questions there? So we've got all of our angles, we're okay there. Let's talk about how you find side B and side C. Again, SOHCAHTOA. It's not a 30, 60, 90. That only works for 30, 60, 90, so be careful there. Right? This is close. It should be really close to being that, yeah. So you're going to have to use trig to solve it. Let's find side B first. Okay. You've got 8, and let's use our 40 degrees. Let's use those two pieces of information. So this is, according to that, 40 degrees, that's the opposite or adjacent? That's the opposite side. You're looking for the adjacent. Opposite and adjacent, that's tangent. So the tangent of theta equals opposite over adjacent. Plug in what you know. There you go. Tangent of 40 equals what? 8 over b. Let me show you how I solve these. Okay. You can't divide by 8 to get b by itself, because b would still be on the bottom of a fraction. You can put it over 1 and solve it like proportion. I've got an easier way. Now, I want you to start thinking about this. How could I move b over here? Multiply by b, right? And then divide by tangent of 40 would move that back over here. So I'll show you the steps this first time, but you can just move this next time, and you won't have to show these steps. To get b over here, since it's divided by b, you're going to do b times the tangent of 40 equals 8. The tangent of 40 is a number. Treat it like a number. You're just going to flip-flop them. And then you're going to move tangent of 40 over here by division. So b is going to equal 8 divided by tangent of 40. So b equals, I'll let you type that in. We'll call it 9.5. So b is 9.5. Okay, now you have options. And listen real close, because one of these options is going to give you a slightly wrong answer. You could use Pythagorean theorem here. The problem with Pythagorean theorem is this is a rounded answer. 9.5 is not an exact answer. If you want this C to be closer, use trig again, because this is an exact answer, and this is an exact answer, and this is. You can use trig again and try to stay away from using 9.5 to find that third side. And trig to me is just as easy as Pythagorean theorem. Let's try to find C. Well, let's see what we're going to use. We're looking for C. Let's use 40 again, and let's use 8. So it's going to be cosine. Is that what you said? So, is it? You can't use 90. You cannot use 90. You're going to have to use either 50 or 40. Because then what's the opposite side? Okay, well, what's the adjacent side? If you use 90, the adjacent side's C. Hypotenuse is C. Adjacent, you have two adjacent sides. Which one's adjacent? Does that make sense? Stay away from 90. It's really confusing. Yeah. Either 40 or 50. I'm going to use 40. So if I use 40, I've got 8, and I'm looking for C. Here's adjacent. Sine equals, well, the sine of my angle equals opposite over hypotenuse. What's my angle? 40 degrees. What's opposite? 8. What's hypotenuse? C. And we've got to do the exact same thing we did before, but we know the shortcut. We're going to move C over, divide by sine of 40, so C equals 8 divided by sine 40, which is 12.4. Does that check out? Smaller angle, smaller side, little bit bigger angle, a little bit bigger side. And the hypotenuse should always be bigger than either one of your other sides. So we solved it. There's all the missing sides and all the missing angles of your triangle. Let's do one more of these. But I really...